We'll proceed in pseudo multivariate calculus. We will see other aspect of pseudo multivariate calculus in which we are pursuing the discussion, and the area of discussion is that how we can have a area vector. Why you are so much worrying about area vector? Anyone would ask, right? Area vector, area vector, area vector. Okay, if you have a if you have a vector, if you have a vector, then if you calculate the magnitude of vector, you will get the length. I believe it is all right. So if I have a vector xi plus yj plus zk, or if I have a vector xi plus yj, if I have a vector xi plus yj, and if I calculate the magnitude of this vector, then it will come at x square plus y square root, or x square plus y square plus z square root. That will be the magnitude of the vector. That is the length of the vector, considering that vector is a position vector and it is connecting origin to a point that is x, y, and z. Very nice it is. So if I have a vector, calculating the magnitude of vector gives the length. Are you serious? Yes. If I have a curve vector, okay, if I have a curve vector, if I have a curve vector, I'm sorry, if I have a curve line, if I represent this line through a vector, if I have a curved line and if I represent this line through a vector, then I'll calculate the magnitude of the vector. Will it really give me the length of this line? Certain. This is the magic of a vector. Okay, we are talking about pseudo mathematical, pseudo multivariate calculus, where we write our code with simple mathematics and slowly it will give the much needed result. Okay, whatever result we are expecting, it will give. That is called pseudo multivariate calculus. Okay, if I need to calculate the length of this line from a point 0 to point x comma y, if I represent this line through a vector and calculate the magnitude of it, it will give the length of this line. Certain. Certain. Okay, thank you very much. Okay, if I represent this surface, if I represent this surface through a vector, and if I calculate the magnitude of vector, will it give the surface area? Certain. This is called pseudo calculus. Think everything in an abstract manner. Think everything in an abstract manner. If I calculate area vector, if I calculate line vector, representation of this curve as a line, if I calculate line vector and then calculate the magnitude, it will give the length of this line. If this is area, if I represent this area through area vector and then I calculate the magnitude of area vector, it will give me the net area. I believe it really makes sense. Okay, what is the area vector of the surface? Previous video, there previous to previous video, we calculated the area, or 2 3 video back. If you see, we calculated the area of a surface, area vector of a surface in Cartesian coordinate system. That came as minus, that came as, what is the area? Area has two sides. If I multiply two sides of the area, then if I multiply two sides of the area, it gives me the area vector. Hop, it gives me the area. If I multiply two sides of a square or rectangle or whatsoever that constitute a two dimension, single dimension, two dimension means it has a width and length. Single dimension, it only has a width or it only has a length. three dimension. It has width, length, and height, three dimensions. So any two dimension constitute an area. Okay, if I have an area, if area, how to calculate area? The pseudo mathematics says that multiply width by length of the two dimension, you will get the area. What funny it is. Where is width and length of this, so that I multiply it and it gives me the surface area? Certainly there would be. The area means width and length is the area. This is pseudo mathematics. Width and length. If I multiply width and length, it will give the area. Okay, this is this is certainly this is certainly not a joke. Okay, what is the basic area? Basic area is a flat surface, and this is one side, or if I take this as origin, this is one side and this is another side. Or if I take this as origin, this is one side and this is another side. This is width and this is length. Width into length is the area. Width I can represent through a vector, because at the end we are representing a length, a line, through vector. So if I say width, what is the width? If this point is origin and this point is x1, y1, if this point is origin and this point is x2, y2, what is the length of this? Then someone would say use Pythagoras theorem. X square plus y square, I'm sorry, x1 square plus y1 square, square root is the length of this. What is length of this? X2 square plus y2 square, square root. Okay, that is same as if I say length of my line is x square, x1 square plus y1 square, square root. This is the length of my line. If this is the length of my line, x1 square plus x2 square, square root, then this is same as the vector length also, xi plus yj. Vector length xi plus yj is x square plus y square, square root. That is the vector length. If that is the vector length, then I can represent this as point origin and point x comma y, x1, y1. Then this width I can represent as a vector, that is x1i plus x2j, y1j. Similarly, this vector will be x2i plus y2j. This vector I can say a vector, and this vector I can say b vector. Now, A vector into B vector will give the surface area. Same thing. Width is the surface area of a flat surface. If this is origin, then origin to point x1, y1, origin to point x2, y2. This width is x1 whole square plus y1 whole square, square root. This length is x2 whole square plus y2 whole square, square root. If that is the case, then this length x1 whole square plus y1 whole square, square root is same as the length of a vector representation, that is x1i plus y1j. If I say this vector as a vector and if I say this vector as b vector, then it is a vector cross b. A vector cross b vector is the net I'm sorry, width. Let us start with the pseudo code. Pseudo code is width into length is the area. Width is x square plus y square, square root into, I'm sorry, x1 square plus y1 square, square root into x2 square plus y2 square, square root is the area. This is simplest form. Now x1 square plus y1 square, square root is same as the length of a vector. Vector is x1i plus y1j, its length, into y2i, x2i plus y2j, its magnitude. Now these two vector magnitude, if I multiply, I get the area. Now I'll proceed. Now consider this vector is A and this is V. Then A magnitude into B magnitude is the area. Now A magnitude, if I take A as a vector and B as a vector, then A vector cross product B vector is called area vector. A vector is called length vector. B vector is called length vector. Cross product of A and B gives the area vector. Okay, so x1I plus y1j cross product x2I plus y2j will give the area vector certain. It will give the area vector. Okay, and area vector will be perpendicular to this surface. So see how we proceed. What is your aim? Aim is to find the surface area of a sphere. What is surface area of this sphere? Don't consider this as a rocket or asteroid or something like this. It is a sphere. If this is a sphere, then what is the surface area of this sphere? That is the question. For that, we started with a simple rectangle. That is the simplest case of the surface area. Now we know that if I have vector A and vector V, if I calculate the cross product of this will give the area vector. Area vector is perpendicular to the surface area. Whereas line vector, if this is a line, the line vector will be along the line. But area vector will be perpendicular to the surface area. What is the area vector? Area vector is A vector cross product B vector. This is called area vector. What is net area? Then magnitude of these two. Cross product means sine theta. Since they are perpendicular to each other, it will be magnitude of A into magnitude of B. Same thing we are doing, right? Magnitude of A into magnitude of B is the area of rectangle. If I come down, then I can say A vector cross B vector. Since cross will sine theta 90 degree, it will pass through. Now we have come to a formula that A vector cross B vector gives area vector. And then doing the cross product of these two, if it gives area vector, then calculating the magnitude of area vector will give me the area. Thank you very much. What is A vector? What is length vector? Length vector is xi plus yj. Many times we have described that length vector, what we are talking about, if this is x-axis, this is length vector. Length vector connecting origin and point x comma y, that is xi plus yj. If I calculate magnitude of xi plus yj, then this magnitude is the length of this line. Okay, that is x square plus y square square root. Length vector is xi plus yj. But problem is this length vector will not work if I have a curved line and this is x-axis or this is x-axis. If this is origin and this point is x comma y, then if I say this curve vector is xi plus yj, it will not work. Because xi plus yj is connecting origin and x comma y in a straight line fashion. If I want xi plus this curve, what is the vector representation of the curve? This curve everywhere vector is tangential. The line vector is tangential to the line. If this is the line vector will be tangent at every moment. That will come as along the line. If I take this curved line as a line, the line vector will be tangent at every moment. This line vector is a group of vector for a curve. But group of vector I can represent through algebra. That is the classic of algebra. Then we saw that the difference between a straight line and a curved line is for curved line y by x. Everywhere y by x is different. For a straight line, y by x everywhere it is a constant. Now I have to represent this vector xi plus yj into y by x. I take out x and it becomes I plus y by xj into x. Okay, or I take out y and become xy yi plus j bracket close into y. Makes sense? I can represent a straight line through xi plus yj vector. For a curved line where y by x is variable, then I'll take out x from it and it becomes I plus y by xj bracket close into x. Because x I have taken out. Now y by x is there. This is the representation of a curved line. Can someone believe it? That any line I can represent it through vector, that is I plus y by xj bracket close into x. If that is the case, then y by x is division. When division is there and numerator is dependent upon denominator, then it will become dy by dx. Okay, so I plus dy by dxj, this will come as x only. Consider y equal to sine x. Then I plus dy by dxj will become a function of sine x only. That function bracket into x, multiplication of two items when one is fx, function over x, and another is x, and x is independent component. This will land up into integral calculus. So any line I can represent it through a vector, and that vector is I plus dy by dxj bracket close into dx, or dxi plus dy by dxj into dx, or dxi plus dyj. But anyway, we will do it in I plus dy by dxj bracket close into dx, or dx by dyi plus j bracket close into dy. Okay, so this is the new representation of a line. Let's go back to the area, calculating the area. A vector cross product of B vector is the area vector, where A is I plus dy by dxj into dx, and B vector, because it is parallel to x-axis, pseudo mathematics. How you can say it is parallel to x-axis? Pseudo mathematics. Try with simple case. And B vector is parallel to y-axis and take out y. Then in that sense it becomes dx by dyi plus j bracket close into dy. Cross product of these two means I plus dy by dxj. If I take in 3D, I plus dy by dxj plus dz by dxk bracket close dx cross product with the dx by dy I plus j plus dz by dyk bracket close into dx. This is called area vector. Okay, okay, I trust you. This is area vector. Okay, I trust you. This is area vector. Now, can you find the area of surface area of a sphere through your great equation, that is I plus dy by dxj plus dz by dxk bracket close bracket close bracket close dx cross product with dx by dx by dy I plus j plus dz by dxk into dy. Okay, that will be resolved in I plus dy by dxj plus dz by dxk bracket close cross product with dx by dy I plus j plus dz by dyk bracket close dx dy. Now x and y, I have to set limit. X and y, if I have a sphere and it is centered at the origin, means center of the sphere is the origin. Top of the sphere is top hemisphere. Top hemisphere is above the xy plane, and bottom hemisphere is below the xy plane. Sphere is centered at the origin. If the sphere is centered at the origin, if a sphere is centered at the origin, one is above the xy plane and one is below the xy plane. Okay, if that is the case, then if that is the case, then if I see the xy plane, makes sense? There is a sphere, and a sphere xy plane cuts the sphere at the middle. Half of the sphere is above the xy plane and half of the sphere is below the xy plane. If I see the xy plane, there will be a circle on the xy plane. That is the limit for the x and y, where x is minus a to a and y is minus square root of a square minus x square to square root of a square minus x square, because it is a circle on xy plane. Makes sense? Okay, what we are talking. Okay, consider this is xy plane. If this is a sphere, then half of the sphere will be above the xy plane and half of the sphere will be below the xy plane. If a sphere is centered at the origin, okay, if I see the xy plane, then at the xy plane this is sphere, will make a circle. And that is the limit of integration for x and y dx dy. Now anyone can try proceeding on this. Now y and x are independent component in Cartesian coordinate system as far as 3D is concerned. If it is a 3D, then y and x are independent component and z is dependent upon xy plane. In that sense, if I do say I have I plus dy by dx, j plus dz by dxk, cross product with dx by dy I plus j plus dz by dxk. If I take these two cross product, then dy by dx is 0 because y is not dependent upon x. And this side dx by dy is 0 because x is not dependent upon y. In that sense, it becomes I plus dz by dxk cross product j plus dz by dyk. Okay, if I do this two cross product, it becomes minus dz by dxi minus dz by dyj plus k bracket close dx dy. This full is called area vector. This is what we have seen. And through this, we have calculated the surface area of a sphere. And it came as 4 pi a square by 4 pi a square. That is the surface area. We did not restrict ourselves with Cartesian coordinate system. Then we went by polar spherical coordinate system. And in a spherical coordinate system, we saw again that net area calculation through a spherical coordinate system, the net area calculation comes at r. So please watch our previous video one day back. In a spherical coordinate system, how to calculate in a spherical coordinate system? In a spherical coordinate system, there are three orthogonal components. One orthogonal component is r. Another orthogonal component is theta, and another orthogonal component is phi. Okay, in that sense, right now what we are doing, we have two vectors. One is called width vector and one is called length vector to calculate the area. Width vector is xi plus yj plus zk. Length vector is xi plus yj plus zk. Okay, now if we take x out and in another I take y out. If I take x out, then it becomes I plus dy by dxj plus dz by dxk bracket closed into x or dx. Cross product, if I take y from other one out, then inside the bracket dx by dy I plus j plus dz by dyk into dy. Cross product of these two. In a spherical coordinate system where we have independent component as radius and then horizontal arc and vertical arc, this xi plus yj plus zk representation of a vector, that is from origin 0, 0, 0 to a point x, y, z. If I see this vector representation, then it is 0, 0, 0 to point x, y, z. That point x, y, z transformed into r vector and then r sine phi theta vector and then r phi vector. That is the spherical coordinate system. Now, what is a spherical coordinate system? Width vector cross product with a length vector is the area vector. That is r vector or r into r unit vector plus r sine phi theta vector or r sine phi theta into theta unit vector plus r phi vector or r phi unit vector. Cross product with the same thing. Now here I take out theta, then it becomes r sine phi theta unit vector plus r by theta. I'm sorry, I'll start with the r by theta r unit vector plus r sine phi theta go away theta unit vector plus r phi by theta theta unit vector. Cross product from that side, I'll take out phi. If I take out phi from there, it becomes r by phi r unit vector plus r sine phi theta by phi theta unit vector plus r, just r because phi gone, r phi unit vector. Cross product of these two vector into d theta d phi, because theta I have taken out, phi I have taken out. If I do this cross product, it comes as sine square, I'm sorry, r square sine phi. If I do cross product, how you do cross product? R by theta becomes dr by d theta. There is no change in r for with the theta in a spherical coordinate system. It's strongly recommended that please watch our previous day video. Anyway, now r by theta is dr by d theta. Change in r with theta is not possible because r is going in different direction and theta is going in different direction. So dr by d theta is 0. Then r sine phi theta unit vector that will remain plus plus r d phi by d theta again 0. Phi does not change with the theta, again 0. This side there is only r sine phi theta unit vector. Cross product. Now another one, r by phi dr by d phi. R by phi does not change with the phi. In that sense, again 0. Then r sine phi d theta by d phi. Again no relationship, again 0. Then r unit vector, r phi unit vector. Now we have cross product of r sine phi theta unit vector and r phi unit vector. Theta unit vector and phi unit vector cross product will lead to r unit vector. All right. And this r into r sine phi, r square sine phi is the net area vector. What is it? Area vector. Area vector is r square sine phi r unit vector and then d theta d phi. Are you serious about it? This is the, yes. See, if this is the sphere, if this is the sphere, if this is the sphere, then area vector will be perpendicular to the area everywhere. Anyone can tell me, if this is a sphere, then what is the perpendicular radius to the surface anywhere? This is the radius vector. Okay, what is your theta vector? Theta vector, if this is the horizontal arc in which theta is moving, then tangent to the horizontal arc is the theta vector. Phi vector, I would read, demonstrated. This is extremely precious. This is r vector that is going from center. Center, there is a radius that is passing. This is r vector. In that sense, theta vector is on xy plane. If there is a circle, then this is the tangent at any point of this line is the theta vector. Phi vector is the vertical arc and tangent at any point is the vertical tangent at any point is the direction of the phi vector. Okay, in that sense, what we received now, r square sine phi r unit vector. R unit vector means center of the sphere. This radius direction is the area vector. That is completely all right. R square sine phi d theta d phi. If someone integrate it, r to the power 3 by 3, r square sine phi. I believe this is the area vector. R square sine phi. Oh, there is no dr at all. R means radius of a sphere, that is a constant. So r, if radius of a sphere is r only or a only, it will become a square or r square. That will come outside r square sine phi. Integration of sine phi is minus cos phi. Phi is 0 to 2 pi minus cos phi 0 to 2 pi will become 2 outside, 2 r square or 2 a square is outside. D theta 0 to 2 pi, 2 pi, 4 pi a square is the area of a surface area of a sphere. So nicely you calculated. Do you have any another thing? Yes, because I do not understand much about your concept that position vector is r vector and then r sine phi theta vector and then r phi vector. Okay, I know one thing that is written in the book, that any position vector of any point on the sphere through a spherical coordinate system is r sine phi cos theta I vector. This is a hybrid model of spherical coordinate system and Cartesian coordinate system. R sine phi cos theta I. This is x part. What is the position vector of any? What is the vector representation of any line? That is xi plus yj plus zk. X is r sine phi cos theta. y is r sine phi sine theta, and z is r cos phi. Okay, this is what I have heard as far as Cartesian and spherical coordinate system. So any point, any line through origin to point P on the sphere, if I have a sphere, if I have a sphere, if I have a sphere and I take any point P and from the center, that is the origin of this, from there if I draw a line that will be radius, radial vector or position vector, that is xi plus yj plus zk. That is line vector. What is your area? A vector cross B vector is the area. A vector is xi plus yj plus zk. Cross B vector is xi plus yj plus zk. That is the area vector. Now, a vector is r, that is the, if I calculating surface area, radius is fixed. R sine phi, phi is angle from the vertical. So this is the phi. If this is the vertical r, this is vertical, then this is the angle it will make. Now phi is 90 degree. Phi is 0 degree, 90 degree and pi degree. Whereas if this is the horizontal, then theta will go 0 degree, 90 degree, pi degree, 3 pi by 2 and 2 pi degree. This is the r, theta and phi. Then we have heard that in a book it is written that Cartesian coordinate you have xi plus yj plus zk cross xi plus yj plus zk. For the Cartesian area vector, in one I took out x and another I took out y, and it become I plus dy by dxj plus dz by dxk. Cross product dx by dy I plus j plus dz by dy k into dy. Okay, but I know one representation of the area vector, that is x equal to r sine phi cos theta, y equal to r sine phi sine theta, z equal to r sine r cos phi. Because if this is if this is the vertical arc, then if this is the center and this is the r and this is vertical, this is angle phi, then r cos phi is the z. R sin phi will fall on xy plane. R sin phi cos theta is x-axis. R sin phi sin theta is y-axis. Okay, can you calculate with your great A cross B is the surface area now, where A is A R sin phi cos theta I vector plus R sin phi sin theta j plus R cos phi. Okay, then as per you, now we have cross product of R sin phi, I'm sorry, R sin phi cos theta I plus R sin phi sin theta j plus R cos phi k. Cross product with R sin phi cos theta I plus R sin phi sin theta j plus R cos phi k. This is hybrid model into Cartesian coordinate and spherical coordinates, because it is again I, j, k only. It is not r unit vector. I means unit vector, r unit vector, theta unit vector, and phi unit vector, whatever it is. What is variable in your surface area? That is theta and phi. Radius is constant if I am trying to calculate it. Okay, then take out theta from one side and take out phi from another side. Then it will make sense. Now it will be it will represent. Now right now x r sin phi cos theta I plus r sin phi sin theta j plus r cos phi, it represents a straight line. You want line vector for the curve, right? Why line vector for the curve? Because if I say that if I'm calculating everything for the simplest case, that is a rectangle, and this is a vector and this is b vector. If this surface area becomes a curve, then this is the curve, and this is again a curve. Okay, then how to represent a curve in a vector and again curve in a vector, that we have seen. To represent straight line in vector is xi plus yj plus zk. But to represent a curve in a vector form, take out x or y. It will become in vector form. So what is your vector form for A and B? For A, take out theta. For B, take out phi. Then it will become a curve vector for A and B. Then do the cross product. So if I take out theta from a sine phi cos theta I plus a sine phi sine theta j plus a or r cos phi k, if I take out theta and make division as differentiation and multiplication as integration, it becomes a sine phi d cos theta by d theta I plus a sine phi d sine theta by d theta j plus a cos phi by d theta, that is 0 because phi and theta are not related 90 degrees, so 0. Cross bracket close into theta or d theta, cross product with the another one. What is your another one? Take out phi from there. I believe this can be taken as an assignment. And if you take out phi, then try to do cross product and try to integrate and see, it will really bring the surface area of a sphere. Mind blowing, amazing, thrilling, hitting head on the wall. Can someone calculate surface area from merely width into length? Width into length is the surface area of the simplest rectangle that comes as xi plus yj plus zk cross product with the xi plus yj plus zk. Now, for curve representation of a for vector representation of a curve of these two, one I take out x and one I take out y, so that the representation of this vector will come in y by x, z by x, and that side x y y z y y. Doing cross product and calculating its magnitude gives the surface area. Mind blowing, amazing. Again, we are trying same thing here. We are taking out theta and there we are taking out phi, so that this the right now the straight line representation, straight vector representation of a straight line is r sine phi cos theta I plus r sine phi sine theta j plus r cos phi k. Okay, and another is again same thing. This is the vector representation of a straight line. If I want vector representation of a curved line, theta I have to take out so that it will become variable. The way I had taken out x. Now I'll take out theta here, I'll take out phi there, and then I'll do cross product and see and then it will come as an area vector. Then calculating the magnitude of this area vector and calculating the integration with the d theta d phi, will it really give the surface area as per our fundamental of pseudo multivariate? This is completely new arena in the calculus, that is pseudo multivariate calculus, where we start any complex problem solving through simple mathematics, multiplication and division, and slowly it grow as a full calculus and vector representation. There we try to find out the solution. Please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number.